Imagine standing on a rocky trail during a hike, feeling curious about the unique boulder that stands in front of you. Have you ever wondered how it formed? What natural forces were involved? Or why does it look the way it does? Well, my name is Kunal, and as a geologist, I can help you unravel some of these mysteries for you. So let's get started. Rocks are basically classified into three types: igneous, sedimentary, and metamorphic. For today, we are just gonna focus on igneous rocks. So, let's explore one of the three main types of rocks, igneous rocks. These are formed from the solidification of molten rock or magma. I like to really think about them as time capsules, which preserve clues about the history of the Earth and the forces that shaped it. By examining the mineral composition and texture and origin of these igneous rocks, we can learn way more about the temperature and the pressure conditions under which they formed. And we can also learn a lot about the chemical processes that occurred during this formation. So join me on this fascinating journey of discovery as we delve into this world of igneous rocks, where each rock tells us a unique story about the natural forces that shaped it. Okay, so let's start with the basics. What does the word igneous mean? The word igneous, it comes from the Latin word ignis, which means fire. So it literally means that the rocks that are made from fire, which makes it quite easy to remember in my opinion. Igneous rocks are categorized on three main types of classification. So the first one being the origin, second one being the texture, and the last one being the mineral composition. So based on origin, igneous rocks can be classified into two types, intrusive and extrusive. Intrusive rocks are formed when magma cools slowly beneath the Earth's surface, where the crystals have a lot of time to grow, and thus we have longer crystals or larger crystals, while extrusive rocks are formed when magma quickly cools on the Earth's surface, such as after a volcanic eruption, for example. So, the intrusive rocks, that is, the rocks that are formed beneath the Earth's surface, have a plutonic origin, while the extrusive rocks that are formed above the Earth's surface have a volcanic origin. So, there you have it. Based on the origin, you can classify igneous rocks as either plutonic rocks or volcanic rocks. So, now moving to the texture, igneous rocks can be determined by the rate at which the molten rocks cools and solidifies. So, you have a much slower cooling at beneath the Earth's surface, which leads to the crystals being larger in size as they have a lot of time to grow. While above the Earth's surface, we generally have rapid cooling procedures which creates finer crystals or smaller crystals, or sometimes even glass. So, igneous rocks with larger crystals are called coarse-grained or phaneritic igneous rocks, while those with small crystals or finer crystals are called fine-grained rocks or aphanitic rocks. In case you were wondering, why magma cools slowly beneath the Earth's surface? Or why does it cool faster above the Earth's surface? Well, actually, there's a reason for this. So there's a process called as conduction, where heat is transferred from one body to another. So this is how the heat is distributed beneath the Earth's surface. Because you see, the magma is surrounded by the other rocks beneath its surface. So the transfer of heat causes some amount of heat loss, and thus the magma cools slowly beneath the Earth's surface. Whereas above the Earth's surface, unlike conduction, here the process known as convection takes place. This is because above the Earth's surface there's obviously a lot of air, and a lot of this heat is lost to this air through convection. Also keep in mind that convection is faster than conduction. Lastly, igneous rocks are also classified based on the mineral composition, specifically on the relative amounts of light and dark minerals. So these light and dark minerals are feldspar and quartz, and rocks with high amount of these minerals are called felsic rocks. And the rocks with high amount of dark minerals, such as olivine and pyroxene, are called mafic rocks. Now, there are also intermediate rocks which have a balanced mix of these light and dark minerals. So, until now we learned how igneous rocks can be classified into different categories based on their mineral composition, texture and origin. However, the most distinctive and significant classification of igneous rocks is based on their silica content, or SiO2 content, commonly known as, which determines their chemical composition and physical properties. So, the three main types of igneous rocks based on their silica content are acidic, intermediate, and basic. Acidic rocks have the highest silica content, while basic rocks have the lowest. Intermediate rocks are intermediate in silica content. So, acidic rocks contain above 65% of silica, while basic rocks contain about less than 40-45% of silica, and intermediate rocks contain between 50 to 65% of silica. So, this classification is significant because it provides insights into the geological processes that form the rock and can help in identifying the rock's properties such as its melting point, density, and hardness. Furthermore, the silica content of the magma also affects the way the rock forms, its texture, and its appearance. For example, acidic rocks tend to be light colored and contain minerals such as quartz, feldspar, and mica. In contrast to this, basic rocks are typically dark colored and contain minerals such as olivine, pyroxene, and the feldspars here are more calcium rich and are commonly known as plagioclase. So, this classification of igneous rocks based on silica content also has important practical applications in geology, mineralogy, and even engineering. For instance, knowing the silica content of a rock can help engineers understand its reliance to erosion, weathering, and other geological processes that affect its stability. Now that we have learned about the classification of igneous rocks, let's take a look at some of the specimens and try to identify them. Let's examine a variety of specimens to challenge our identification skills. So let's go! This is the first specimen. You can pause the video here and try to classify it based on the texture, origin, and mineral composition. So let's start with texture. As we can see, there are a lot of grains here. Some pink colored grains, some white colored grains, and some black colored grains, which we can easily separate them just by looking at them and not even using a microscope. So we can say that this rock is coarse grained, and we can call it pheneritic. Now, so as the crystals are large, they definitely needed a lot of time to cool down. So I would say that this was beneath the Earth's surface. We can say that the rock is intrusive or plutonic in origin. Finally, based on mineral composition, so we can see that we have a lot of white and pink colored minerals. So the white colored are quartz and the pink colored is a feldspar. This pink colored feldspar is known as orthoclase. So we can see that these light colored minerals dominate the dark ones. So we can say that the rock is felsic as it is composed mostly of light colored minerals. We have a few dark colored minerals. These are not olivine or pyroxene, but this is mica called biotite. So based on the mineralogical composition, specifically on mineralogical composition, we can say that this rock is a granite, because granite typically has a composition of quartz, feldspar, and biotite. Now let's take a look at another specimen. Again, feel free to pause the video and try to identify it on your own. So, let's start with texture again. So based on texture, what do you see here? We see almost no individual mineral grains, as we saw in the previous specimen. So we can say that the rock is fine-grained or aphanitic. As the grains are so fine that we have to use a microscope to see the individual grains, so we can say that the rock was formed above the surface of the earth, where there was rapid cooling and the rock cooled down relatively quickly. So we can say that the rock is an extrusive igneous rock and has a volcanic origin. Now let's try to classify this rock based on mineral composition. So we can see that the rock is black in color, which means that it is composed of dark minerals, which we cannot see here. So just based on the color, we can say that the rock is mafic, which basically means that the rock is composed of dark colored minerals like amphiboles, pyroxenes. We can't really see the mineral grains here, so we cannot know the actual name of the rock. In order to identify this rock, we need to take a look at its microscopic section. I will make a separate video on this if you're interested. So let me know down in the comments if you would like to see a video of identifying fine-grained rocks by looking at their microscopic sections. Okay, so for now, based on texture, the rock is aphanitic, fine-grained. Based on origin, it's volcanic, and based on its mineralogical composition, it's mafic. So the name of the rock is basalt. However, we cannot call it basalt just by looking at its physical properties. We need to take a look at its mineralogical composition through a microscope. Okay, so now let's take a quick look at how basalt looks like under the microscope. So basalt is really hard to identify even with a microscope because it can consist of a lot of types of minerals, and these selection of minerals can vary from region to region. So for now, let's take a look at a simplistic example. So as you can see in this figure, we have two sections. We have PPL and XPL. PPL means plane polarized light and XPL means cross polarized light. The microscope basically has these two functions. So in the plane polarized light, we can see a lot of these small tiny black grains. These are mostly oxides, and which generally is about like 20% of the entire rock, but here we can see a lot of them. Okay, so the main minerals that we need to take a look at is the pyroxenes and the feldspars. Feldspars, you can see them at the top section of the XPL part of the image, where in the center you can see a pyroxene. So even under the microscope, we can see that there are still a lot of fine-grained crystals that we still cannot identify. However, there are quite a large group of crystals that occur in between the fine ground mass. So this type of texture is known as porphyritic texture. So I don't really want to go too deep into this because it would be a much longer video. So just to make it short, basalt is typically composed of olivine, pyroxenes and plagioclase. Okay, now let's take a look at a few other igneous rocks. I'm not gonna go too much into detail. The rock that you see here is an obsidian. As you can see, it looks like glass. So here, the crystals had absolutely no time to form, and as a result, what you get is a glass, a natural variety of glass, and this is called an obsidian. So you can call it fine-grained, aphanitic, igneous rock that has a volcanic origin and is composed almost entirely of SiO2 or silica. Some of the most commonly known igneous rocks are andesite, rhyolite, gabbro, pumice, tuff, pegmatite, peridotite, and the list goes on and on and on. If you would like to know any of the rocks that seem quite difficult for you to identify, just let me know down in the comments and I can make a separate video which would not be as long as this. I would make it quite short. Hey guys, it's Kunal here. Thank you so much for watching the video. If you think you have learned something and would like to support me, the link is in the description. You could buy me a coffee, and it would mean the world to me if you would like the video and subscribe. Thank you so much once again for watching. I would also like to shout out my friend real quick. His name is Niranjan, also link in the description. He made the music for my intro and for the outro of my video. Thank you so much again. See you in the next one. Goodbye.